And the next mechanism will be the reaction of the diethyl ether with aqueous acid. And important to note that when we have both water and sulfuric acid, what we really have is H3O plus and sulfate, right? Either hydrogen sulfate, HSO4 minus, and or SO4 2 minus. So if we want to, when we protonate our ether, we can use the H3O plus as our acid. We could also use sulfuric acid. Either one is fine. Although it's important to remember our chemical principles, the reaction between these two is really not an equilibrium, or if we think of it as such, it's heavily forward favored. And so we would really have in that reaction mixture a combination of hydronium and the conjugate bases of sulfuric acid. So this gives us a protonated oxygen. We generally protonate our oxygens to make them good leaving groups when we're doing a substitution reaction. And now we have a pair of carbons which could conceivably be our electrophilic center. And it really, in this case, doesn't matter because they're both primary and they're both ethyl groups. So either carbon we react at will give us the same result. If we didn't have a symmetric system, or if we had a secondary or a tertiary carbon, then we would want that leaving group to leave and then Sn1 style to give us a carbocation. Since it's primary, then we're going to do Sn2. So our water attaches to either side. We break that oxygen carbon bond. That gives us one alcohol, and it gives us a second alcohol that's protonated. At this stage, we just need to pick up the extra hydrogen to make that second alcohol neutral. We can use another equivalent of water to do that. So we come in, we break that extra OH bond, and that will give us our second equivalent of ethyl alcohol. So we've actually got two of these. And notice that that is essentially the reverse reaction of the dimerization of an alcohol to make an ether. If we think about that in terms of a balanced reaction, we have an equilibrium between the ether and the alcohol, or sorry, the ether and water, and then two molecules of the alcohol. So if we want to drive that equilibrium in the forward direction, the trick is to add a lot of water. Take advantage of Le Chatelier's principle, add a bunch of water favors the forward direction of the equilibrium. Questions there?